Hello students, today's my topic is events and types of events. Now, events means what? A subset of sample space is called as the events. For example, consider the experiment of tossing two coins simultaneously, then sample space is omega is equal to H T TH and TT. This is the sample space. Now on this sample space, event A is defined. Event A is such that at least one head occur. At least one head occur. Then event A contains the outcomes H T and TH. The event A contains the outcomes of the sample space omega. So therefore here event A is subset of omega. Okay, this is the concept of event, that is, it is the subset of sample space omega. It's called as the event. Now, types of events. The first type of event is simple event, or it is also called as the elementary events. First type is simple event. If event containing only one sample point, then the event is called as simple event or elementary events. Or a singleton set is called as simple event. For example, suppose omega is equal to HT. This is the sample space. On this sample space, event A is as only head occurs. Only head occurs. Then event A contains outcome H. This is a singleton set. Therefore, event A is called as simple event or elementary event. Then second type of event is impossible event. Second type is impossible event. Definition of impossible event is an empty set is called as an impossible event, or if event does not contain any sample point, then the event is called as an impossible event. For example, suppose we have a sample space contains the outcomes one, 2, 3, 4, 5, 6. This is the sample space. Now we define event A on this sample space as number greater than 6 occurs. Number greater than 6 occurs. Therefore, event A is an empty set. It does not contain any sample point. Therefore, it is an impossible event, or it is called as null set. Third type of event is sure event, or it is also called as the certain event. Third type, sure event. It is also called as the certain event. If event containing all possible outcomes of sample space omega, then the event is called as sure event or certain events. For example, suppose sample space contains the outcomes 1, 2, 3, 4, 5, 6. Now define one event on this sample space. Event A is as natural number occur. Natural number occur. Then event A contains the outcomes 1, 2, 3, 4, 5, 6. In event A containing all the points of the sample space omega, therefore event A is called as an sure event or certain event. Now next type of event is, that is fourth type of event is mutually exclusive. Mutually exclusive events. Mutually exclusive events. Suppose capital A and capital B, these are the two events defined on the sample space omega. By using Venn diagram, we have, this is our sample space omega. On this sample space, two events are defined, A and B. Then these two events A and B are said to be mutually exclusive events if A intersection B is equal to phi, that is an empty set only. There is no common elements between A and B. It is called as the mutually exclusive events, or it is also called as disjoint events. Okay, now we see one example. Suppose we have a sample space which contains the outcomes 1, 2, 3, 4, 5, 6. On this sample space, two events are defined. Event A is equal to odd number occur, odd numbers occur, and event B is equal to even numbers occurs. Even numbers occur. Then event A contains the outcomes. A is equal to, in curly bracket, odd numbers, that is 1, 3, 5, and event B contains the outcomes. Event B is even numbers occurs, which contains 2, 4, 6. Then common elements between A and B, that is A intersection B is equal to, which is an empty set, that is which is equal to 5. There is no common elements between event A and event B, therefore A intersection B is equal to 5. Hence, the events A and B are said to be mutually exclusive events. Then, next type of event is exhaustive events. Next type is exhaustive events. Suppose A and B, these are the two events defined on the sample space omega. Then these two events are said to be exhaustive events if A union B is equal to omega. If we take union of two events and which is equal to sample space omega, then the events A and B are said to be the exhaustive events. For example, now consider the sample space which is considered in the previous example. Omega is equal to 1, 2, 3, 4, 5, 6. A is equal to 1, 3, 5 and B is equal to 2, 4, 6. If we take union of A and B, which is equal to 1, 2, 3, 4, 5, 6, which is the sample space omega. Therefore, the events A and B said to be the exhaustive events. If we have more than two events, in that case, suppose we have n events. A1, A2, A3, so on, An. Then these n events are said to be exhaustive events if A1 union, A2 union, A3 union, dash dash dash, union An is equal to omega. Generally, we can write for n events in this way. The union of all events is equal to the sample space omega. Then the n events are called as the exhaustive events. The next type of event is complementary events. Complementary event. Consider sample pace omega is equal to 1, 2, 3, 4, 5, 6. And we define event A as an odd number occurs. That is 1, 3, 5. On this sample pace, event A is defined. Then the complementary event of A is denoted by A dash. A dash is the complementary event of A, which contains the elements of sample pace omega but not the elements of event A. Event A contains the outcomes 1, 3, 5. Now, ignoring these 3 elements from the sample pace, then A dash containing the elements 2, 4 and 6, that is, which contains the elements of sample pace omega, which contains the elements of sample pace omega but not the elements of event A. This is the concept of complementary event. Then we see the occurrence of at least one events out of the given events. Occurrences of at least one events. Suppose we have 2 events, capital A and capital B. These are the 2 events, and these 2 events are defined on the sample pace omega. Then the occurrences of the at least one events out of A and B is the A union B. This is the expression for the occurrences of at least one events. Suppose we have n events, A1, A2, dash 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 an. These are the n events. Then the occurrences of at least one events out of the given n events is A1 union A2 union A3 union dash 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 union AN. Then next one is simultaneous occurrences of the events or occurrences of all the events. See, next one is occurrences of all given events. Okay, suppose we have 2 events, capital A and capital B, and these 2 events are defined on the sample pace omega. Then these 2 events are said to be simultaneous occurrences of events, means expression for this is A intersection B. A intersection B means simultaneous occurrences of both events A and B. For n events we can write A1 intersection A2 intersection A3 intersection dash 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 intersection AN. That is, these n events can be occur simultaneously, or all of the given events occurs. This is the expression for the simultaneous occurrences of the all events. Then next one is exactly one event occurs out of the given events. Again, suppose we have two events A and B. Then expression for the exactly one event occurs out of A and B is what? A dash intersection B. In this case, here event B only occurs, A does not occurs, or A intersection B dash. In this case, event A occurs but event B does not occurs. That is, exactly one event occurs out of the two events A and B. Then next one is relative complementation. Relative complementation. Suppose we have two events, capital A and capital B are the two events, and these two events are defined on the sample space omega. This is sample space. On the sample space, event A and event B are defined. This is event A, this is event B. The common region between event A and B is denoted by A intersection B. Then this region is denoted by, this is A dash intersection B, and the remaining part is this one, this shaded region. This is denoted by A intersection B dash. Then the relative complementation of event A with respect to event B is A dash intersection B, that is, which contains elements of B but not the elements of A. And the relative complementation of event B with respect to event A is A intersection B dash, that is, which contains elements of A but not the elements of B. And this is the common region between event A and B is the A intersection B. This is the relative complementation.